If you're taking notes, great, but if you don't have that opportunity, it will be available tomorrow on our YouTube channel, and we'll send out a notification to everyone that's joined up for this webinar on the link to be able to review this presentation again tomorrow. So, first of all, thanks for everyone for joining us. I know everyone's busy out there getting ready for compliance or being compliant, so an hour of your day is much appreciated from us. And from our perspective and the response that we've had to this webinar, with about 100 people signing up, there's obviously a real need out there for some knowledge sharing with regards to this MATS rule and specifically PS12B and Appendix A compliance when it comes to the Mercury portion of this legislation. So today we're going to talk about what we do here at Apex to help out with MATS regulation, which is our Mercury system, and how you can be compliant with sorbent trap monitoring and the implications for PS12B and Appendix A in being compliant. We hope that the information today we share with you is accurate and is informative for you, and that we've done our best to get the knowledge that we've gathered from being out in the field with a lot of you out there, as well as doing our own research with the legislation. But before I get started, I wanted just to address real quick, we do have everybody muted out there so everyone can hear us nice and clearly. We are planning on having a session at the end of the webinar for questions. Again, with 100 people possibly joining us, it could get a little crazy with questions coming down. So what we're proposing here is if everyone has questions during the presentation, if they want to email me directly, there's my email address on the screen. And while my colleagues here in the room are presenting, I'll monitor my email for questions that everyone may have, and then have the possibility of presenting those at the end of the presentation anonymously, if you like, to bring up some points of discussion that everyone would like to know more about. So speaking of colleagues and people here in the room with me, again, my name is Mick Zilpo. I'm the Director of Sales and Marketing here at Apex. I've probably dealt with a lot of you out there. I'm also here with Mr. Chris Green. Chris is the Director of Business Development for Apex, and Chris over the last few years has been specifically focused on our Mercury line of products, and a lot of you may have spent some time in the field with Chris, so say hello.
Good afternoon, everyone.
Also joining us today is Mr. Jim Cothran. Jim is head of our Engineering Projects Division. Jim spends a lot of time with our programmer developing the software for our automated systems, which include our Mercury systems. And Jim does a lot of our troubleshooting as well out there in the field, as well as offering advice and support to everyone using our systems, especially when it comes to DAS integration and a lot of the aspects that have to do with the software. So Jim's going to do some presenting for us today, and I'd like to thank Jim for joining us.
Thank you. Welcome, everybody.
So here's a quick overview of what we're going to try and achieve today. I'm going to briefly touch on the history of MATS and some of the most recent developments out there that everyone may have heard of. Then talk about how the Mercury portion fits into the MATS legislation and how it differs a little bit from the other aspects of MATS that everyone has to be compliant with out there. Then Jim's going to take over, just refresh everyone and make sure they understand about our sorbent trap system and what in general a sorbent trap system looks like. And then we're going to get to the meat of our presentation today, which is obviously the Performance Specification 12B and how that relates to the MATS compliance. And also we're going to touch then on the Appendix A part of this, and that's where Chris is going to take over, and he's going to talk about the 7 aspects of Appendix A and some of the key components to help everyone out there understand what they need to do to be compliant. We're going to touch on the reporting aspects of the Mercury MATS legislation, discuss a little bit about downtime, spares, and all of those fun things that come up when we're using a system to be compliant with the legislation. So that's a basic overview of our webinar, and then again at the end of it we're going to have some questions and discussions about everything out there. I mentioned to everybody that we're going to be recording this session and posting it on our YouTube channel. There is our link. If you were to go to YouTube and search for Apex Instruments INC altogether, you'll be able to find our channel. Currently, we already have a couple of Mercury webinars out there to do with the MATS legislation in general. Apex Instruments, our Mercury webinar, and then a webinar specific to our sorbent trap monitoring system. So if anyone hasn't seen those and would like to view them, they're already out there on our YouTube channel. And then, as I iterated earlier, we're going to post today's webinar out on that same channel tomorrow for everyone to review. So everybody out there is probably well aware of this MATS legislation because you're joining us today, but it's been a while in the making, obviously stemming all the way back to 1990 from the Clean Air Act that was implemented here in the United States. We had the first go-around that a lot of you may have dealt with back in 2005, issuing the CAMR, and then having that vacated in 2008, and a lot of the equipment that everyone was using kind of put on hold, and everyone not knowing where things were headed. A year after that, we had the Supreme Court deny a couple of things that the EPA were trying to achieve. And then in 2011, we had the MAC and the MATS rule come into effect, and that's kind of what we're discussing and dealing with today. From my understanding, a lot of people were trying to be compliant with last year. However, a lot of our people that we've had relationships out there with the field were able to get a one-year extension, and from my understanding, looking at being compliant around April of next year. So obviously with the 100 people joining us today, there's a lot of people still looking at compliance and looking at next year and what's involved, so we're happy to share with everybody what we know. Recently, a lot of you may have heard that the Supreme Court up in DC ruled against the EPA back in June. With regards to the MATS legislation, and a lot of that was based around the way that the EPA neglecting costs in its approach to implementing this regulation and the cost benefit to the cost of you guys implementing this law, and how that trickles down to the general health benefits of all the citizens here in the U.S. The reason I bring this up, and I want to be very clear about this, is the Supreme Court ruling against the EPA back in June does not vacate the MATS rule. We're all still moving forward and trying to be compliant, and that's the way that we need to view this until we hear any differently. But from our understanding, it's still going forward, so we're here to help everybody in any way we can to become compliant. So in general here, the MATS and Mercury rules, which a lot of you are familiar with, obviously there's several aspects of this MATS legislation, not only Mercury, but filterable PM, HAPs, and a couple of different things. So as many of you may know, a lot of these other elements that fall under the MATS legislation are based on quarterly testing. However, in the field of Mercury and what we're talking about here today, it is based on constant reporting. And the next slide will show you that Mercury must be constantly monitored 24/7, 365 days a year based on your operating hours. So that's where we stand today in terms of being compliant for PS12B and Appendix A. So At this point in time, I'm going to hand over to Jim Cothran, who is going to take it from here and discuss with everybody some specific parts of PS12B. Over to you, Jim.
All right. Thank you, Mick, and good afternoon, everybody. We're going to discuss the PS12B performance spec. It actually explains the scope and application of how, what, when you can use and operate a sorbent trap monitoring system. Provides a good definition of the principle of operation, the equipment, and significantly, the QA/QC requirements for a sorbent trap monitoring system. Directly from the actual performance spec, this is a high-level diagram of the monitoring system. The sample gas is pulled through a pair of traps at the end of the probe where the mercury is collected on the carbon media with the traps. The sample gas then flows through the probe down the heated line to a moisture knockout, creating a dry sample. The sample is then sent to the dry gas meter, which records the sample volume so it can be compared to the amount of mercury collected to produce a mercury concentration during the sampling period. PS12B also states that sampling must be performed proportionally to the stack flow. This is simply taking a flow signal from a source monitor, feeding it into the system, and controlling the sample flow. We'll talk more about proportional sampling a little bit later. This is a picture of our system. It's a typical configuration that's available in multiple configurations. You start out with a heated probe where your traps are mounted. That is used to flash off the moisture, prevent condensation in the traps and the actual sample gas moving down through the heated line. As it comes into the chiller removes the moisture, providing a dry sample that is then measured in the console. Console itself measures the sample, records it, and controls the actual sample flow during the test. Laptop is used for test setup, audits, and beginning maintenance procedures. Also provides a network configuration into your DAS system for real-time monitoring of the system's operation, and remote access for monitoring the system. Each sorbent trap monitoring system shall be continuously operated and maintained in accordance with Performance Spec 12B. The QA/QC criteria for routine operation of the system are summarized in the table 12B-1 within the Performance Spec. Each pair of sorbent traps may be used to sample the stack gas for up to 14 days. However, in our experience, 7 days is more of a normal operation. Several reasons. One, of 14 days, if something happens to a trap, you've now lost 2 weeks of data. The trap gets lost in the mail, broken, dropped. 7 days, it's a smaller batch and provides a better sampling rate. Section 4.2 states that the relative accuracy test, or the RATA, must be performed for initial certification of the sorbent trap monitoring system. Acceptable reference methods for performing the RATA are defined in Section 4.1.5. The initial certification, or the RATA, as described, will typically must be within 20% of the value. You also must make sure that you use the same types of traps and same media for both of the tests. Both sets of traps must meet the QA/QC tolerance requirements as specified in the method in the QA/QC sections. Another aspect of PS12B is you're required to record moisture. This can be done either from a method 4, which you should already be doing under Part 75. However, Apex has petitioned the EPA to allow us to do volumetric determination of stack moisture by using the condensate collected during the sample run. However, this has not been approved yet, but we're working on it. This alternate has been approved to be used on method 30B. You also can use a default value based on the type of coal that you're burning to record your actual moisture. The problem with that could be you might be reporting at an invalid rate compared to what you really are, and either reporting higher or lower mercury than what you really have. Okay. All right, proportional sampling. Right. Per the spec, basically proportional sampling has to be done on an hourly basis and then verified against your starting hour. So during the first hour of your sample period, you divide your stack flow by your sample flow and then apply a factor to it to give you essentially a value that will give you between 1 and 100. Then for each subsequent hour, you perform the same calculations and deriving another ratio, then compare the two ratios, and they must be within plus or minus 25% of the first hour ratio. Proportional sampling itself is basically, all we're saying is whatever your stack flow changes, you have to change your sample rate. Baseline establishes your starting point, and then from that point on, any change in stack flow, increase or decrease, we will change the sample by the same percentage. Below is an example. You can see baseline, if you start out with 300 cc as your sampling rate with a stack flow of 1,000 KSCFM, if the stack flow increases to 1,100, you'll see that it's a 10% change, and my sample rate will increase to 330 cc. We do this real time during the entire test, from the time you start to the time you end. Okay, all right, so establishing the baseline is probably the trickier part of having a successful run. To select the baseline starting point, you must know what your expected stack flow will be, and you also need to know what the average range expected during the sample period and what is the current stack flow. If the current stack flow is at a high end, you would select a starting point higher, allowing the rate to adjust downwards. Baseline starting point will not be the same for each run. That's something that needs to be, you can't just keep running the same profile over and over. It should be adjusted based on what your starting point is. And what I usually recommend out in the field is to use a simple chart or a spreadsheet. All you need to do is look at what your stack flow is, and it'll calculate up or show you what you should use for your starting point. Where it gets trickier is when you have wide swings with stack flow, specifically if you're running at 80% stack flow and starting a test at a higher sample rate. As the stack flow drops, the STM will stay within its operating range. Opposite is true, you're starting at a low stack flow and start at a lower rate. The actual sorbent trap itself is made up of three sections. Primary capture, this is where the actual mercury is collected and measured to determine what your mercury concentrations are. The second two sections are really more of your QA. The center section there is called breakthrough, and it's to verify that the mercury is not migrating through the trap. So anything more than 5% of what my primary capture section is would show that you have excessive breakthrough. The last section, or the spike section, is actually starting out with a known value of mercury, and during analysis it determined that that mercury is still there at between 75 and 125% of its original amount. Again, this is to verify that mercury is not being bleached or burned out of the trap during the sample run. Another aspect that's important to keep track of is to make sure the serial numbers are recorded. As you can see in the picture on the screen, the actual serial numbers are either etched into the glass or printed. The software itself, my software actually records that at multiple places. We also do recommend that your testers record this information either in a notebook, which is also a good idea to keep track of any kind of maintenance issues, comments, etc., just as a log of the system. And also, traps come with a chain of custody, which determines, the date when the trap was run, etc. These should be filled out completely as the test begins and is ended. The sorbent trap system requires a quarterly audit. Once the initial RAT has been completed, quarterly audits are performed to verify the system is still within its operating parameters. Primarily, you're verifying barometric sensors, vacuum sensors, critical temperature sensors, and the dry gas meter. And we just have a couple examples of what would be in our toolkit, if you will, to do our audits. This is a handheld barometric sensor. It is traceable. Comes with a certificate. or vacuum. It's a digital vacuum gauge. It is also traceable. The thermometer, it is traceable. However, we've found it's actually less expensive just to replace it every year than it is to send it in, because the recertification of the thermometer is actually more expensive than purchasing a new one. The reference flow device, it's a mass flow device that we use for verifying the dry gas meters. Again, this needs to be recalibrated annually by the vendor. And as an earlier option of our audit kits was a secondary reference meter. This was a 15-point calibrated meter that was used to verify the dry gas meters in the console. Again, this must also be sent back. This can be sent back to Apex for validation annually. And the last part of the kit is an ice bath. It's a wide mouth thermos. It's used to ice and water and verifying your thermocouples, which also includes the stack probe. It's also, you can also just use a bucket of ice, whatever's easier. That's what a lot of my stack testers I work with end up using. Good thing about this, it does not require any calibration. On the quarterly audit, just a high note for our current users out there. If you want to use the reference flow device, or the AlleyCat that I showed earlier, you must be at software version C50723-109 or higher. If you're still using the secondary reference meter, there's no need to change your software. It works with all versions. Okay, now we're going to talk a little bit about the QA/QC criteria. Primarily, you have pre-leak and post-leaks, 4% of your sample rate. The pre-leak is done at whatever your starting or your baseline target sample rate was. Your post-leak is actually done at what the average sample rate of the entire test was. Also, vacuum levels during your pre-leak are done at maximum vacuum, and at the post-leak, you're done at the maximum vacuum observed during the test. The ratio of stack and sample gas we talked a little bit about already. It must be no more than 5% of them can fail of those 1 hour periods, and all those have to be within 25% of the original hour reference period. Sorbent section, we touched on this briefly when we talked about traps. The Section 2 or the breakthrough section must be less than 5% of what was captured in Section 1, or less than 10% if you're under half a microgram per cubic meter. Paired sorbent agreement, we already talked there. Dual traps, they have to be within 10% of each other when you get to your concentration against comparing the two. Either if they're not, you can either take the highest value or invalidate your test. Okay, this list really deals more with the analyzer used to analyze your traps. But your spike recovery study, your multi-point analyzer calibration, and analysis of independent calibration standards. This is either done by you if you're doing your own trap analysis, or if you're going through a contracted lab to do your work, they should be performing these and provide documentation saying that they are, just for your records. Okay, next. Spike recovery, we touched on earlier. Again, it's 75 to 125% of your spike amount. The relative accuracy, this is when you're doing your RADI, you must be within 20% value that was collected during the 30B testing. Gas meter calibration. Gas meters, new systems are all calibrated at a minimum of 3 settings. We're actually moving more to a 10-point calibration. We've been using dry gas meters for over 30 years in our systems, with over 10 years experience using dry gas meters in our automated sorbent trap systems. Lots of experience with them. They're easy to calibrate and easy to verify using a reference device, secondary reference meters. The sample volume is much more reliably monitored, recorded using a dry gas meter, so meeting requirements of PS12B are easily achieved against reference meter. There's no requirement for any kind of bottled gas, stat gas. Again, that's making it easier to audit and calibrate. Barometer and temperature are pretty straightforward. Again, the temperature sensor, we're looking at plus or minus 1.5% of your reference, and your barometer within 10 millimeters of your reference device. Both of these are provided in the audit kit, and as I said earlier, they need to be sent back. The barometer would need annual calibration, and the temperature sensor, we recommend replacement every year. So just from a summary of the QA/QC, trying to boil it all down and make it simple, we have pre and post leak checks that have to be less than 4% of your sample rate. Proportional sampling has to be plus or minus 25% of your ratio. Your traps, paired trap agreement, 10% relative deviation. Right through the section of section 2, spike recovery, 75 to 125%. Calibration audits, your dry gas meters, 5% of the reference point, temperature sensors, 1.5%, and barometer, plus or minus 10%. Annual RADA, and we talked about the annual RADA is required. So that's what I'm going through. We're seeing a couple questions popping up on the on our chat line, so we're making some notes of these, and we'll kind of come back and address those. And for now, I'm going to hand this over to Chris, and he's going to be talking about Appendix A.
All right, thanks, Jim. Jeff, I've seen your question there. We'll come back to you at the end of my session, I guess. So we'll definitely answer you. Okay. What I'm going to do, I'm going to talk a little bit about Appendix A and how that really fits in with the compliance requirements. From the slide that's now on the screen, EPA have issued some reconsideration of certain startup and shutdown issues, and that the final rule will contain 3 alternative approaches for measuring mercury emissions during startup or shutdown periods. And the first approach, owners or operators will be able to continue to use mercury SEMS. The second approach relies on at least 2 separate sorbent trap monitoring systems, one for startup and one for continuous running. The third approach, of course, relies on just one sorbent monitoring system for all periods of operation. So, like I say, mentioning this section, Appendix A, to Subpart UUUUU, I'm actually going to just refer to this document as Appendix A. This is where your monitoring program and equipment requirements may well become a little bit more onerous. We've already spent some time looking at all of the QA specific items that have to be achieved to conform to PS12B. And we're pretty comfortable that our sorbent trap monitoring systems will meet those requirements fairly easily, with a high degree of automated data collection, data recording during each sample run. Appendix A really takes you, the plant owner operator of the sorbent trap monitoring systems, to an area where you've got to consider your monitoring strategy. Within Appendix A, we start to see the definition of monitoring system installation requirements, primary and backup monitoring systems, redundant backup systems, non-redundant backup systems, and temporary like-kind replacement analyzers. And perhaps importantly, for how long we can use non-certified systems. Appendix A tells us 720 hours before a RATA must be performed and passed. 720 hours or 30 days. Not a great deal of time to perhaps get your primary system repaired and back in use, or more importantly, to organise a rata test for the replacement equipment. I've listed here the 7 elements of Appendix A. Each of those headed sections do give a lot of detail of what's required by your measurement system and reporting. As in the review of PS12B, I'm going to look at some of the highlights of the significant clauses. For solvent trap monitoring systems, Appendix A constantly refers back to following the procedures as defined in PS12B. Appendix A is written in the language of government, so not always easy to understand or to find items of relevance as it switches from talking about SEMS and back to solvent trap monitoring. Although there are, of course, common requirements for a SEMS monitoring approach and a solvent trap monitoring approach. It mentions a quality assurance operating quarter, which means a calendar quarter which there are at least 168 operating hours, 7 days. Within Section 1 of Appendix A, General Provisions, Paragraph 1.4 tells us there is no need to substitute missing data, but any data not obtained is counted as an hour of downtime. If using a single solvent trap monitoring system and this was returned to us for repair, then no monitoring would mean missing data. If the unit was repaired and returned to you, there are no immediate recertification requirements other than to meet daily, weekly QA requirements, then the next quarterly audit, and eventually to pass the next rata test. Each state will have a formula for penalising all of the missing data. Bearing in mind, operating days will reduce the above numbers. Section 2 focuses attention on backup systems, a redundant system located on the same unit or stack on hot standby. But this redundant system must be certified. A non-redundant backup monitoring system is certified at a particular stack or unit, but not permanently mounted at the same sampling location. So this non-redundant system is available on cold standby and can be used at the stack location for a maximum of 720 hours per year. To use a non-redundant system at that stack location for more than 720 hours, a rata test must be performed and passed at that location. So Section 2 of Appendix A provides guidance on what you need to do if your primary monitoring system is not working. Section 3 describes in detail the procedures and definition for the calibration, use of calibration gases for a SEMS Mercury analyzer system. It also describes what additional information is needed to report in heat input-based units, pounds per trillion BTU, or electrical output-based emission limits, pounds per gigawatt hour. And finally, it describes that a solvent trap monitoring system must have a certified stack gas flow rate monitor to provide a signal to the STMS to maintain proportional sampling. A big advantage for a solvent trap monitoring system is that for that initial certification of the solvent trap monitor, only a rata test is required. We've already seen the QA/QC criteria for routine operation of the system as listed in Table 12B-1 of PS12B. For ongoing quality assurance of your solvent trap monitor, annual ratas are required. Records of preventative maintenance and all testing, maintenance records, a maintenance log, date, time, repair, replacement must be kept. For each solvent trap sample collection, the sampling console collects and automatically records all of the sample run data. Section 6 outlines data reduction. It's quite specific, specific on how to report data and carry out calculations, to report in hourly averages for any operating hour. Any hours without valid data are considered as downtime. Section 7.1 states record-keeping provisions. For the Mercury SEMS and or solvent trap monitoring systems and any other monitoring systems installed at each affected unit, the owner or operator must maintain a file of all measurements, data, reports and other information required by this appendix in a form suitable for inspection for 5 years from the date of each record. So basically, downtime. No downtime is allowed for each sampling system. We will have rental systems for emergency support, but there will be a limit on numbers. Units returned to us for a repair, probably at best 2 weeks from leaving your site, arriving here and returning to you. So there is, of course, a significant cost penalty. The cost to be able to collect compliance data, measurement, or the cost to pay the penalty for missing data. Finally, in Section 7 of Appendix A, it gives detail of all that is required in reporting requirements to the EPA. Electronic quarterly submittals, certification and recertification of QA test submittals. EPA recognised that submitting electronic PDF reports is not as desirable as reporting the data in extensible markup language, XML format, because the information in a PDF report cannot easily be extracted and put into a database format. An additional data revision will be phased in by April the 16th, 2017. Finally, that reporting string, the Excel report string of what information is required. And with that, I'm now going to hand you back to Mick. Thank you.
Thanks, Chris. So we've got a couple of questions coming in, but before we jump to that, I just wanted to touch on a couple of things. Now we've shared with everybody the requirements for PS12B and Appendix A and how Apex as a vendor partner may be able to help everybody out there with some of their concerns on being compliant and making sure that they're reporting data constantly. So a couple of things that we're addressing from the feedback we've been getting in the field. One is we're coming out with a new software update. And this new software load is going to allow everybody out there, as long as they have the new AliCat device as part of their audit kit, to do in-field calibrations of the mass flow and dry gas meters in our systems. There has been shared with us concerns that some of our partners out there are keeping spare parts on the shelf, whether it be Manivisos or whether it be dry gas meters that have calibration certificates attached to them, which obviously have a 1-year shelf life on the calibration. So there was concern that these parts will go out of date before they had a chance to use them. So to share with everybody, the new load that we're working on that hopefully will come out in a couple of months will have the ability to do these in-field calibrations. And what we're trying to achieve here is basically an automated calibration procedure. So you'll hook up your AliCat device to your Apex system, on the screen, hit calibrate, come back in a little while, and the calibration procedure would have been performed for you. And all that information recorded for record keeping and things like that. So that's one thing that we're working towards to help everybody out in the field. Chris touched on this before, the possibility of not having any downtime and what that means for everybody out there. We have some customers that have gone ahead and purchased basically backup systems, non-redundant backup systems to keep it on site. We have some partners, for example, that may have 4 systems throughout their organization as their primaries, and they have one as a backup to be able to hotshot out to whichever location they need to be using it. For those of you that have limited resources, we understand that, so we're going to make a commitment from Apex to have a short-term rental fleet available. As Chris touched on as well, that is somewhat limited to our resources here, but we're going to do the best we can to have calibrated, ready-to-go systems on the shelf that we can pretty much send out to you overnight if you have a catastrophic failure of your primary reporting device, and do our best then to turn around whichever device that you send into us to get it back out in the field to get reporting again. We've also had some requests from some partners out there to put together a service agreement for you. Basically, the request that we've had is they're looking for some more either remote or on-site support from our technical service department here at Apex. And a lot of you have had interactions again with Jim and David Allen and Jackson Yarborough in our service department. But what we're looking to do is put together an agreement that will give you a little bit more access to certain things that we can help you with. The way that we're going to set up this service agreement is going to have a base agreement with certain things such as 24/7 phone support and other aspects of the base agreement. Then we're going to have an a la carte menu that you can add per your needs, whether it be periodic visits from one of our field techs to come out, maybe perform the orderly quarters for you, look over the system for preventative maintenance, see how the system's performing, come out and do periodic field training, refresher courses, as a lot of, we understand some people, like in any industry, we get a turnover of people using these systems, and it's just relevant to come out and do a refresher course and get the new people out there exposed to the equipment and make sure it's being used correctly. So hopefully we're going to have that service agreement completed by next week. So if anyone's interested in that, reach out to me here at Apex, and I'll be happy to share that with you. So let's get to some questions. We've had a couple come in, so I'm going to start there talking about that. So first of all, I wanted to address one of the questions here. What options are available for significant instrument failure that requires off-site maintenance? I hope I shared that with everybody in terms of either having the backup non-redundant system on site already. If you have those resources, can do that. The other option is reach out to me. I'll share with you what we can do in terms of our rental fleet and the prices associated with that for a couple of weeks, keeping that up and running while we're repairing your system. We have another question here regarding the dry gas meter. Are we referring to the mass flow meter such as the AliCat? Jim, would you want to speak to that? This one here from Lance there. Regarding dry gas meter. Basically, in our systems, when we're talking about mass flow sensors and dry gas meters, they are two different things.
The mass flow sensor within our console is basically used to measure the sample rate, but the actual volumes that are used to calculate your mercury concentrations are all done via the dry gas meter, which is a volumetric device.
We also have another question here with regards to quarterly flow audit. Is there a specific flow rate and sample volume requirement for this quarterly audit? I have heard different values from different people, 0.3 liters a minute for total volume of 10 liters, 0.5 liters a minute for 5 liters, etc. I want to pass that over to Jim. I think he can.
Yeah, the minimum requirement is the dry gas meter needs to make 3 full revolutions. Our gas meters are 700 cc's per revolution, so at a minimum you'd be at 2.1 liters. As far as the actual sample rate, it would be your average sample rate used during your testing. So if you're normally running at 400 cc's, that's what you want to do your audit at. Normally, when I'm doing training and working with customers, I recommend 5 liters when we do the audits. So a bit more than just the basic 3-turn, but again, 3 is the minimum. The 2.1 liters on 3 revolutions.
We just got another email question in. Do you offer a blank that can close off the stack penetration while the traps are being changed out so that the flue gas does not enter the work area where you're working? Yes, we do. We have a flange cap that can easily go on there and works just like the cam lock. It snaps right over that flange cam lock fitting there when you pull the probe out, and that'll keep that flange capped off while you're either doing your audit or changing your traps or whenever you need to do that. So if anyone's in need of those, please reach out to myself, and I'll happy to quote you those caps for the flanges that you have out there. Chris, do you want to answer this question? Can you address what the penalties are for missing data?
Yeah, we don't really know what the penalties are. We've heard from different states that they will vary, they will be different, so I can't give a very general rule as to what that will be. The indication is that it could well be less expensive to buy a second system. And that's probably, I'm not trying to push our systems, but the penalty for missing data sounds like it might be quite onerous.
All right, we've got a couple more questions coming down the line here, so I'm just going to read them in order that came in and point to either Chris or Jim to help us out with the answers here. We do have a question. You mentioned a chart showing stack flows and related starting points. Is this something that you have developed, or should they be developed by the site? If we are developing them, do we have guidance about how this should be done? And I believe this is related back to the
proportional sampling.
Proportion sampling in 1 hour.
The actual chart you develop is it's based on what your stack conditions are. I'd be glad to help you. Just if you kind of email me some numbers and things, I can probably show you a rough idea. I don't have an example of it right now, but basically it's a column of, here's my stack flow on the left column, and on the right column will be, all right, here should be my starting point.
Okay. I believe we maybe have one that we've drafted up for a site specific, but again, the values will change. But if anyone wants to email me directly, I'd at least be happy to share with you the template that we've been using in some other locations. We do have another question here. Does PS12B have any probe temperature requirements?
No, it's basically your probe temperature, not the probe. You're more concerned about keeping the traps hot, but obviously not too hot. Generally, we recommend around about 30 degrees above stack temperature. Now, the trap temperature will be controlled first before the probe temperature.
Now, just to expand on what Chris was saying there, and the reason we're saying this is that we obviously want to keep that sample above the dew point to stop any condensation coming down the lines when you are sampling. However, we don't want to take our probe temperature above a certain point, and what we recommend here at Apex is about 400 degrees for extended periods of time. And the reason we recommend that is it's that point of temperature where you start seeing issues with spike recovery and burning off some of the mercury capture that you're getting on your probes. If you are seeing extended periods of temperature above 400 degrees, we do recommend using a air-cooled probe to bring that temperature down to make sure that the mercury capture that you're getting is okay, and you're getting a representative sample of what's coming in the stack there. Just to answer Larry, yes, we're still recording, so we are going to have this Q&A portion of the webinar right there on our YouTube channel. Anyone who wants to email me with regards to anything we've talked about today, email me directly. Again, I don't know if my email's there on the next one, Chris, or not. You can see my email there at the bottom, and we'd be happy to help anybody out. I might just go ahead and have Chris unmute everybody, and in case we have any questions that anyone would like to share with us over the voice link, we'll go ahead and get that open for you. Just hit all there on the other side. Okay, are there any recommendations? We just got another question here. Are there any recommended trap shields for wet FGD applications?
Our normal individual trap shields should provide protection in that sort of environment. Wet FGD, yeah, it's really just, you've got to sample and see how long you can sample for. You may not be able to get the full 7 days. A little bit of trial and error.
What we do have available is everything from 4, 5, 6-inch up to 12-inch trap shields that we've had out in the field. We have had some success with the longer trap shields, especially when it comes to particulate buildup and getting a little bit extra time out of the sample, maybe switching from 5 or 6 days to 7 days. So again, it often comes down to site specifics, but we're happy to help anyone out there that has that as well. And we just got a note here that trap shields have worked for us as well. So we do have some customers out there using them on a regular basis. Please keep in mind the trap shields, even with a Hastelloid probe, we do recommend buying stainless steel just for the fact that they are significantly cheaper than a Hastelloid trap shield. And it's one of those items in the system that we really view as a consumable item. They're pretty easy to lose. They are exposed to a lot of nasties in the stack, so they do need replacing periodically. And I'd rather you guys drop a cheaper piece of metal off the stack than a more expensive one and have to come back and replace it. So our recommendation is stick with stainless steel and replace them a little more regularly than going with the Hastelloid. We do have the voice link open. Is there anyone that would like to ask any questions verbally over the voice link right now? No, doesn't sound like it. Great. Well, thanks everybody for attending. I think we've covered all the questions that came through here on the link. If we didn't, apologies, but please send them to me directly, and we'll answer them for you. And then I'll send an email out to everybody tomorrow with the link so everyone can review what we went through today. Thanks, everybody. Have a great afternoon.